Alright, so today we're actually going to take those rational functions that we've been solving. Well, we're going to take up one particular type, the rational parent function, and we're going to learn about its transformations. Nice thing about the transformations is you've seen these before. You know how your transformations work. You've been doing them all year. Okay? Well, before we can get into transformations, we've got to decide, okay, what does the rational function look like? Okay? Now, the parent function, okay, so our parent function for the rational function is y is equal to 1 over x. Okay, so to figure out what it looks like, let's plot some points. So when we plug in -2 in here, that'd give me a -1/2. Plug a -1 in, that'd give me a -1. Now what happens when I put a 0 in? Well, can you divide by 0? No, you cannot divide by 0, so we're going to call this undefined. Plug a 1 in, that would be a 1. Plug a 2 in, we're going to get a 1/2. Alright, so there's our 5 parent points. Let's see what that looks like for a second. Alright, so we're going to plot them. -2, -1/2, -1, -1. 0 undefined, can't do anything with that. 1, 1, and 2 1/2. Alright, so that doesn't give us a whole lot of graphing periods. So let's kind of talk about what else could we do. Okay, so those are parent points. But what if I put a 3 in? Well, 1 over 3 would give me a third, correct? What if I put a 4 in? Well, that'd be 1/4. A 5 would be 1/5. A 6 would be 1/6. And notice, I would get smaller and smaller and smaller, but I'm never going to touch. So the way this graph is going to go is going to go closer and closer and closer, and it's not going to touch right there. Okay, same thing on the negative side. I put a -3 and I get a -3rd, then a -4th, and then a -5th, but it's never going to touch. It's going to go closer and closer and closer and closer. Okay, now what that does develop for us is we get closer and closer to this barrier, we get closer and closer to this barrier, but it never touches. And so we have what's known as a horizontal asymptote. Okay, that horizontal asymptote we're going to show as a dotted line. Okay, that's down here. It says since 1 over x will never reach 0 exactly, we have a horizontal line at y is equal to 0. Okay, it's called a horizontal asymptote. Asymptote. Okay, so the p is silent. Okay, and we represent it as a dotted line, and it just is a somewhat of a barrier. It gets closer and closer and closer, will never touch, like cutting something in half. You can keep cutting, theoretically you can cut something in half forever and ever and ever and ever and never get to nothing. Okay, well, that gives us that part of the graph. But what about if we start going this way? What's going to happen going towards 0? Now remember, we can't get to 0. Okay, and so if I plug in, let's just even say we plug in a 1/2. If I plug in a 1/2, that's the same as 1 divided by a 1/2. If you remember your old math skills, that's 1 times 2, which is 2. So technically at 1/2, comma 2, which would be here. And then the same thing for a third, in here. And notice we end up with the same thing that happened on the horizontal, but now it's going to happen on the vertical. It's going to go this, and it gets closer and closer and closer to the y-intercept or y-axis, and it'll never touch. So we're going to have the same thing, but vertically, a dotted line. Okay, so we're going to have a slashed or a dashed vertical line at x is equal to 0, and that is my vertical asymptote. Okay. Now, when we start transforming those are going to move, and we're always going to write them as an equation. But notice the line is at x is equal to 0. That's the vertical asymptote, and we're going to go VA for vertical asymptote. We're going to go HA for horizontal asymptote. And this one is at y is equal to 0. This one is at x is equal to 0. Alright, so what about its domain? Well, its domain, all your x values. Well, all these x values work and all these x values work. But the only x value that doesn't work is 0. So, it's going to be all numbers except for 0. So, I don't know which way you like to do your domain. One way in set notation will be x is such that x is the element of all real numbers except x can't be 0. I tend to like interval notation, which would be negative infinity to 0, union 0 to infinity. Depends on which way you like to write it. Okay, range, well, that's the farthest down to the farthest up. Well, all of these y values work, and all of these y values work, except for 0. 0 is the only thing, where that asymptote is. So, it's going to be y such that y is an element of all real numbers, except y can't be 0. Or if interval notation, negative infinity to 0, union 0 to infinity. And that is my domain and range. Okay? Now what we're going to do is, on the next video, we're going to actually transform this. In other words, we're going to slide this, we're going to move them up and down, we're going to vertically stretch, vertically compress, horizontally stretch, horizontally compress. And we can actually also flip. Okay, so to get us transition to that, we're going to look down here and look at transformations. So in the rational function, this is going to be our transformations, in which we're going to have a function, okay, and it's going to be a over b times x minus c plus d. Well, those should be all letters we remember. Okay, so remember that a is your vertical stretch or compression, and if a happens to be negative, it's a reflection of the x-axis. In other words, if a is negative, this branch comes here and this branch comes here. Okay, b is your horizontal stretch and compression again, and if b is negative, then it is a reflection over the y-axis, which means this branch would come over here and this one would come over here. Okay, and then c and d, like it always been. C is your translation left or right. Okay, d is your up and down move. So your translation left or right, remember, if you would have 1 over x minus 5, well, that's going to be right 5. And then your d is your up and down move. So if you have 1 over x minus 5, that's going to be a down 5. Notice where they're at. This is in the denominator, this is outside the fraction. Okay, just like it's always been. Okay, so that'll be actually in our next video. So hope this helped, and once you've got this, then you can go to your next video.